Hello, I have a question from 2.3. It's graphing linear equations. This is a topic that was taught in Math 103 or Math 102, whichever way you went. So this is a review topic, but it's graphing equations in the form of ax plus by equals c, which is the general form of a linear equation. Now, I wrote down a little recipe how to do this. It's fairly simple. So you solve the equation x plus by for c, for y, ax plus by equals c for y. And you to place it into y equals mx plus b. So if you solve for y on this equation, it turns out that mx plus b is what you come up with. Now, m is the slope, and that's the rise over the run, and the b represents where it crosses the y-axis, which is what we call the y-intercept. And so that's what we're going to do in step 2. Step 2, it says identify the slope and the y-intercept, which is 0, comma b. On the third step, you're going to place 0, comma b on the coordinate system. And then you're going to use your m, which is rise over run, to find an additional point. And then after you found those 2 points, then that's all you really need. You just have to sketch the line that goes through those 2 points, because like you learned in high school geometry, 2 points determine a line. Okay, so that's what those 2 points are going to do. Now I want you to recall, I put this down, and it's not just for lines, it's just for any graph that you actually ever do in a college algebra course. But a line represents the solutions to the original equation. So that graph is the solution to a linear equation. It's a line, it's a solution to a linear equation. But any graph that you'll ever do in this course corresponds to a particular equation. But that graph, once it's done, is a set of ordered pairs. And all those ordered pairs work for that original equation. So when I say graph, another way to say that is saying find all the two-dimensional solutions. That's probably another way to say it. So anyway, I wrote an example up here, 3x plus 5y equals 15. And like I said before, I want to solve for y. So if I do that, I get 5y equals negative 3x plus 15. So I'm subtracting 3x to the other side. And then it's divide by 5 on everything. So you get y equals negative 3/5 x plus 3, because 15 divided by 5 is 3. Now, solve for y. The number in front of the x is negative 3/5. That's your slope. That's your m. So m is negative 3/5. And if you missed the lecture on this in class, now remember, m is used for slope because the word slope had an adjective on it about a few centuries ago that meant modulus slope. That was the actual word, modulus slope. And so eventually they just dropped off the word modulus, but they kept the m hanging around for the letter that they use for slope. So that's where the m comes from. So and then the y-intercept is 0, comma 3. Okay, so you locate 0, comma 3, and that's your y-intercept right there. And then you use the negative 3/5, which is your slope, and you'd go down 3 because negative 3 goes down 3 units, and then 5 units to the right. So you're right there. Okay, so down 3 and over 5, and that finds you a new point. You can do this again if you wanted to. You can go down 3 and over 5 again. And if you do this multiple times, all those points are going to line up. They're collinear. They all lie on the same line. But anyway, you only need really 2. So assuming we make no mistakes, that is your second point. That point is actually 5, 0. Okay? So 5, 0, you can actually verify this is the other point by testing that point in the original equation. So if you go back to the original equation, 3 times 5 plus 5 times 0, if you do the math on that, that should be 15. And that's what it is. So that's kind of a quick check. But these are just 2 points on the line. And so you graph the line that connects those 2 points. And I'm not a very good artist, and I'm not very good, I can't draw a straight line sometimes. But this line right here represents all the ordered pairs for this equation. Okay, now understand what this graph is. That's when I was recalling what this is a while ago. What this is basically saying If you see this point right here and you're like, I don't know exactly where that's at, somewhere between the -2 and the -3, and the y coordinate is somewhere between, what, 4 and 5. So I don't know really the exact location of that point is. I'd be guessing if I had to. But whatever that point is, I'm going to call it AB just generically. But I can tell you one thing about that point. It's a solution to that equation because it's on the line. On the same token, this point right here that is off the line, I know it's not a solution just simply for one reason. It's not on the line. So this point is not on the line, so therefore it's not a solution to the equation. So that's what I was saying a while ago. I said that when you're drawing the line is a representation of all the 2D solutions to that particular equation. So it's all the ordered pairs that work for this. And the reason you do a line is because there's an infinite number of points that work. So, but anyway, that's the purpose of graphs to begin with. But this one's fairly simple. You just have to solve for y, identify the slope, and identify the y-intercept. Place the y-intercept and then use the slope, rise over run, to find an additional point. And you can do it 2 or 3 times if you want, but you only really need 2 points on that graph to do a line. And then connect those 2 points on the line, and that's pretty much it. So, but this is 2.3, problems 71 through 90. This is pretty much how they all would work when they are in this form. So, all right, that's it.